Hi, my name is Jamie Beattie. I'm here to present our paper, Automatic Diagram Creation for Design of Testbenches, that was co-authored by two of my colleagues at CreVinn Teoranta, Paul O'Keefe and Gian Lorenzo. The aim for this project was to build a tool using available open source tools to create diagrams of RTL and testbenches for specification and training purposes. This tool will be integrated into the design and testbench flow to allow specific diagrams to be automatically regenerated throughout the design cycle. Types of diagrams that you want to generate using this tool are design and test bench hierarchical diagrams, clock and reset tree diagrams, and design connectivity diagrams. Before beginning, we looked at our commercial tools available for this task. Xilinx Vivado was most promising, although it did not produce a standard of diagram that we were looking for. This diagram shows the intended flow and integration of the tool with the existing design and test bench. Starting with the design and test bench, we first have to extract information from it and output in a readable format for our diagram tool. To do this, we worked with three different tools. Verilator is an open source simulator tool that also parses the design and produces an XML representation of it. A Python script was then developed using the py.dot library and existing Verilator Python functions. This script was used to generate a dot file from the Verilator XML output. A dot file is the file type used by the graph visualization software GraphViz. Verilator is still being worked with as an option for this tool, however, it would probably have to exist as a separate flow to the normal design test flow, which would result in extra maintenance. The Verilog Perl tool is an open source building point for Verilog support in the Perl language. It was used to create a script to output a CSV file produced from the design and test bench. However, as with Verilator, this script exists as a separate flow to the normal design test flow, and Verilator seems to be a more effective tool for this use. The System Verilog verification procedural interface provides a library of C language functions that can be used to extract information from System Verilog design and test benches. We use the VPI integration with the Cadence Exilium simulator to develop C programs. These programs use VPI functions VPI scan and VPI iterate to traverse the design hierarchy, capturing all the design and test bench information required to generate GraphViz dot files. These VPI programs can be easily integrated with an existing design flow to run with an Exilium Xrun script. There were then two different open source diagram creation tools explored. GraphViz is an automatic diagram creation tool which takes a dot file as input. It was a very effective tool for a number of reasons. It can be installed on a Unix server and executed through the command line. It generates diagrams very fast in a number of output formats, including PDF. The automatic layout is very effective, particularly for hierarchical diagrams, and there are plenty of layout and design options that are customizable. However, unfortunately, it cannot produce diagrams that are editable. The dot layout is the main layout that we've been using with GraphViz. It is used for the generation of hierarchical and clock and reset tree diagrams. It's easy to use and produces good quality, easily readable diagrams. The Serco, 2Pi, and SFDP layouts are also of interest to us and are used in the creation of design connectivity diagrams. This is currently a work in progress, and we've so far seen that these layouts are much less effective when being used to diagram large numbers of signals or modules. The second option explored was diagrams.net. Diagrams.net is a free online diagram editor which includes an option to import a diagram in CSV or XML format. The main advantage of diagrams.net is that once the diagram has been initially created, it is then editable and nodes and connections can be moved about freely. This makes it a promising tool for diagrams that are too busy for GraphViz to automatically generate a clear, well-spaced diagram. However, its clear disadvantage is that diagrams.net always requires some manual intervention and so it cannot be fully automatic. This diagram is an example of what can be automatically produced using the VPI functions, GraphViz tool, and Xrun script integration mentioned previously. As you can see, the diagram shows the module hierarchy for modules below the dot. A number of options can be defined to configure the output diagrams. The top level module is one of them. Another option is the number of module levels that we wish to include in a diagram. You can see that in this case it is 4. One option is to highlight key blocks in the design. This is shown by placing a box around specified module groups. You can see that each module has a list of the number of inputs, outputs, and inouts to the module. Clocks and resets present are also listed. These are both configurable options. So as you can see, this tool is working effectively for automatically producing hierarchical diagrams, and this flow will be incorporated into future projects at CreVinn. The creation of design connectivity diagrams is ongoing and will likely use both GraphViz and diagrams.net, depending on the complexity of the diagrams being created. Overall, this investigation has been a success and progress on the tool will continue.